welcome to Sangam tutorials. We speak Gubbi online classes for Ncert 10th standard and Cbse 10th standard for mathematics and science classes. So in today's session we will be going with polynomials, very important concept. So in the last class we had discussed regarding the different types of polynomials, monomials, how they are formed, binomials, trinomials and polynomials that is of different types. So if they have a single term, that's a monomial, it's two terms, a polynomial has two terms, then it's a binomial, and say if it has three terms, it's a trinomial, and we came to the degree of the polynomial. So in the degree of the polynomial, if the variable x has degree 1, then it is called a polynomial which is of degree 1. So if it has, the variable has degree 2, that is 2 as power for the variable, then it is called a quadratic polynomial. Then we came with cubic polynomial, then we came with biquadratic polynomial. So yesterday class we have discussed all these things. So in today's session we will be learning regarding the value of a polynomial, we will be learning zero of a polynomial, and then we will be learning the most important part of the session, that is the geometrical meaning of polynomials. So how graphically or geometrically these polynomials can be presented, and how can we analyze the zeros and values of a polynomial. So in particular we are going to analyze how the zeros of the polynomial are formed. So I hope at the end of the session you will be masters in this. So in the first topic we will be going with the value of a polynomial, which you have already learned in your previous class. We will revise that once again, because based on that, the today's concept, that is geometrical meaning of polynomials, that is zeros of the polynomials, is standing on it. So therefore first we will go with the value of a polynomial, then we will go with zeros of a polynomial, then we will go with the geometrical meaning. Right. Okay, let us consider a polynomial p of x. So it's a polynomial in x. So what are the polynomials we are dealing in this chapter will be of same variable, that is the polynomials in one variable. In a polynomial all the variables will be x, or in a polynomial all the variables will be y, or in a polynomial all the variables will be z something, but not x, z, y, all different types of variables are not mixed in a single polynomial. So those type of polynomials we are discussing. So this is p of x. So p is the name of the polynomial and x is the variable used inside the polynomial. So let us take this. Let p of x is equal to x square minus 3x minus 4. Some polynomial is there. So now at this stage I will not discuss whether this is a polynomial or not. All those things are over. So here it is understood that whatever the examples we take in this chapter are 100% polynomials. Right. So p of x is x square minus 3x minus 4. We have a polynomial here. So we will put x is equal to 1. Let's see what happens. So in place of x, we are going to substitute that by 1, or we are going to replace x by 1. So that becomes, as we are replacing x by 1, that becomes p of 1 is equal to 1 square minus 3 into 1 minus 4. So p of 1 is equal to 1 square is 1 minus 3 minus 4. So p of 1 is equal to minus 3 minus 4 is minus 7. 1 minus 7. So p of 1 is equal to 1 minus 7 is minus 6. So here we have a value that is minus 6. So now, so here we speak about value of polynomial. So how to analyze the value of a polynomial? So now you are given with a polynomial, some polynomial you are given with, and you are asked to replace the value of x by some real number, that is 1 I have taken in this example. So as I replaced x by 1, I have got this value at the last. So in this polynomial, if x is replaced by 1, then the value of the polynomial will be equal to 6. Then the value of the polynomial equal to 6, that is minus 6. So once again, a polynomial was given to you, you replace the value of x by 1, you substituted the 1 in place of x wherever it is, and you simplified that and you have got this solution as that is minus 6. So here minus 6 is called the value of, that is the value of p of x. Minus 6 is called the value of p of x when x is equal to 1. So that's the meaning of this. So if you put x is equal to 2, the value of the polynomial changes. If you put x is equal to minus 2, the value of polynomial changes. If you put x is equal to 3 by 2, then the value of the polynomial changes. So as you go on giving values for x in the polynomial, the value of the polynomial goes on continuously changing. Let us go with another value. Let us take p of x is equal to x square minus 3x minus 4. I have taken the polynomial. So I will put x is equal to minus 2. I will take negative value here, which is also a real number. So p of minus 2 is equal to minus 2 whole square minus 3 into minus 2 minus 4. So p of minus 2 is equal to minus 2 whole square is 4, minus into minus is plus, 3 2s are 6, minus 4. So p of minus 2 is equal to plus 4 and minus 4 cancels, and the remaining is 6 here. So here the value of the polynomial is 6. So here you were given a polynomial, you substituted the value of x, y minus 2 and you simplified, you got 6 as the answer. So here 6 is called the value of this polynomial when x is equal to minus 2. So when you go on changing the values of the polynomial, that is the value of x, the value of the polynomial goes on continuously changing. So this is what we call the value of a polynomial. That's very simple. So this comes in your exam for 1 mark in your multiple choice questions. So you will be given a very simple polynomial. If p of x is equal to some x cube minus 3x plus 2, find the value of p of 1. So there in place of x you have to substitute 1. So in some examples, if p of x is equal to x plus 3, find the value of p of minus 2 something. So there you have to substitute minus 2 in place of x and find the value of p of minus 2. So this is how it comes. So this is a very simple thing, value of a polynomial. So once again, minus 6 is the value of this polynomial when x is equal to 1. So plus 6 is the value of this polynomial when x is equal to minus 2. So therefore, as we go on giving values for x, different real number values for x, the value of the polynomial continuously goes on changing. So it depends. Now, if p of x is a polynomial, if p of x is a polynomial and k, for example, is a real number, and k is a real number. P of x is a polynomial, that is what we have taken here, and k is a real number, that is in place of x we are substituting 1, so 1 is considered to be k, that's all. So k is a real number, so it can be anything, any value you can take. A real numbers, you know, it's a huge combination of all rational numbers and all irrational numbers taken together. They are called as real numbers. You have studied in your 9th standard classes. So k is any real number, any number you can take. So then p of k, that is we substitute the value of k in p of x, that is in place of x we put k, that is in place of x as we substituted 1 and we started simplifying that, then p of k is called value of k. P of k is called as the value of p of x when x is equal to k. So this is how you have to understand this. If p of x is a polynomial and k is any real number you can take, any real number, then p of k is called the value of p of x when x is equal to k, which is denoted by or represented by p of k. So this is the definition for the value of a polynomial. So it's very important. Now let us go with the zero of the polynomial. 0 of a polynomial. It's very important. Don't forget this. This plays a very important role for the geometrical meaning of p of x. Right. Now observe this. So p of x, let us take a polynomial here. So x square minus 3x minus 4. I have the polynomial here. So in this polynomial, let us put x is equal to minus 1. Let us substitute x is equal to minus 1. Now, when we substitute x is equal to minus 1 in this polynomial, it becomes p of minus 1 is equal to minus 1 whole square minus 3 into minus 1 minus 4. So p of minus 1 is equal to minus 1 whole square is 1, minus into minus is plus, 3 ones are, it is 3 minus 4. So p of minus 1 is equal to 1 plus 3 is 4 minus 4. So p of minus 1 is equal to 4 minus 4 is 0. So this is a very important result what we have got. So what is the difference there? Difference is there. So if in p of x in the last problem what we substituted, we got some 6 and minus 6 as values. So in this polynomial we have taken x is equal to minus 1 and we have got 0. That's all. It's not that's all. It is everything. It is that's it. It's not that's all. It is that's it. That's very important here. See here, when you have substituted the value of x is equal to minus 1 in the place, that is minus 1 in the place of x, and you simply simplify, you got 0. In the sense, you made this polynomial p of x equal to 0. You made the polynomial p of x equal to 0 by substituting x is equal to minus 1. In the sense, this minus 1 made p of x to become 0. So therefore, here as the p of x value of p of x, as it becomes equal to 0, p of x becomes equal to 0 because you substituted x is equal to minus 1. Therefore, minus 1 is called as the 0 of the polynomial. Minus 1 is called the 0 of the polynomial. So many students at this point they get confused, right? They may say, what is this? Something like that. That may be their feelings, but actually it's very meaningful here. You have to remember this. You had been given a polynomial. You were asked to substitute the value of x is equal to minus 1. You substituted that. You simplified. You got 0. You made p of x equal to 0. That is, p of x becomes equal to 0. So, if p of x becomes equal to 0, the value which made p of x to become 0 is minus 1. So, therefore, minus 1 is called 0 of polynomial. It is called as 0 of polynomial. You have to remember this, right? Let us take another example. Let us take another one. So p of x is equal to x square minus 3x minus 4. I will take the polynomial. I will substitute a value. Put x is equal to 4. I will take 4 and I will substitute this. Okay, I will take minus 4. So p of minus 4 is equal to minus 4 whole square minus 3 into minus 4 minus 4. So in place of x I have substituted minus 4. So p of minus 4 is equal to minus 4 whole square is 16. Minus into minus is plus. This is minus into minus is plus. 3 4s are 12. It becomes minus 4. So let us take plus 4. Okay, 4 square is 16. Minus into plus is minus here. So 3 4s it is 12 and it is minus 4. So p of minus 4 is equal to 16. Minus 12 minus 4 is minus 16 again. So p of minus 4 is equal to, cancels and the value is 0. So again the things repeated here. So what happened here is, you were given a polynomial and you are asked to substitute the value of x which is equal to 4. When you substituted the value of 4 in the polynomial and you simplified that, at last you have got 0 as the answer. In the sense, you made this p of x become equal to 0. So which value made the polynomial equal to 0? That's very important question. What value of k, in the sense as I told you earlier, what value of k, that is the real number here, made the polynomial p of x equal to 0? Here x is equal to 4 made this polynomial p of x equal to 0. Right? So therefore 4 is called as 0 of polynomial. 0 of polynomial. So please remember this. So like this, how many values are there to make p of x, that is x square minus 3x minus 4 equal to 0? So here only minus 1 when substituted to this polynomial and 4 when it is substituted to this polynomial only can make p of x equal to 0 and also p of x equal to 0. Other than minus 4 and 4, minus 1 and 4, no other value of k, that is no other value of a real number apart from minus 1 and 4 can make this p of x equal to 0. So therefore for x square minus 3x minus 4, for this quadratic polynomial we have 2 zeros. We have 2 zeros. That's very important. It has 2 zeros. It doesn't have more than 2 zeros. So we usually say that for a quadratic polynomial there are at most 2 zeros. At most means maximum 2 zeros. It can also have 1 zero. It can also have no zeros. A quadratic polynomial can have no zeros. It can have 1 zero. To the maximum it can have 2 zeros only. A quadratic polynomial cannot have 3 zeros. Please remember this. So zeros of a polynomial in this concept it is very important. A polynomial was given to you. You are asked to substitute the value minus 1. When you substituted this value, p of x becomes equal to 0 only. Exactly it is equal to 0. So minus 1 made this polynomial p of x to become 0. Therefore minus 1 is called 0 of this polynomial. Maybe minus 1 may be the 0 of some other polynomial, we don't know. We don't know that. But here minus 1 is 100% the 0 of this polynomial, because when you substitute this value in this, p of x becomes 0. So in the same manner, x is equal to 4 is the 0 of the polynomial, because when it is substituted in the polynomial, it makes p of x equal to 0. Therefore 4 is also the 0 of this polynomial. So a quadratic polynomial can have at most 2 zeros. Right? That's the major statement. Quadratic polynomial can have at most 2 zeros. Okay, then it may have 1 zero also. It may have no zeros also. That's the possibility. So when I come to geometrical meaning of polynomials, I will show you how it comes, how 2 zeros comes. Okay. So this is how it goes. This is very important. You have to remember this, right? Okay. For example, here p of x is equal to x plus 5. I have a polynomial. So it's a linear polynomial. Why it is called a linear polynomial? Because the value of, that is the exponent of the variable, is equal to 1. That is degree of the polynomial is equal to 1. Therefore it is called a linear polynomial. So now let us see how many zeros are there for this polynomial. Right? So put x is equal to minus 5. I hope you are guessing it. So p of minus 5 is equal to minus 5 plus 5. So p of minus 5 is equal to, it cancels and it is equal to 0. So you are given a polynomial, that is a linear polynomial. You substituted the value of x is equal to minus 5 in that. When you substituted the value in this value x is equal to minus 5 made this polynomial p of x become equal to 0. Therefore minus 5 is the 0 of polynomial. It's called 0 of polynomial. So like this, for this linear polynomial, how many zeros can exist? So here for a linear polynomial, only one zero exists, because the degree of the variable here is equal to 1. Therefore, 1 0 exists. So, for a linear polynomial, at most there is 1 0, or a linear polynomial can have no zeros also. So, why here in quadratic polynomial we have 2 zeros? You can easily guess. The variable has the highest degree as 2 here. Therefore, it has at most 2 zeros. So, can you guess for the cubic polynomial now? It's very easy. P of x is equal to x cube minus x. Some cubic polynomial is there. How many zeros are there for that? So, as it is a cubic polynomial, at most there are 3 zeros. It can also have 2 zeros. It can also have 1 zero. It can also have no zeros. All the 4 possibilities are possible. So, I will show you while going with the geometrical method. Okay, I hope you understood this. So, we will go a little bit depth into this. I will show you how I guessed minus 1, and how I guessed this 4, and how here I guessed this minus 5. So, first I will show you for the linear polynomial. So, now please observe this. P of x, this is a linear polynomial. It is in the form of ax plus b. So, this is the general form of a linear polynomial, what I showed you in the previous class. So, ax plus b is the polynomial in x. So, therefore, we will equate this. Ax plus b is equal to 0. Why we should equate the linear polynomial to 0? Because if you want to get the zeros of that polynomial, you have to equate that polynomial to 0. That's very simple. So, you need the value of x. So, x is equal to, that is ax is equal to, plus b goes to the RHS, that becomes minus b. So, x is equal to minus b by a. So, that is minus b by a is the 0 of this polynomial. For this polynomial, x is equal to minus b by a, if you substitute here, then you will get the 0 of that polynomial. Let us check it. We will check this. So, x is minus b by a. Okay, let us go with this. So, p of x is equal to a into x value is minus b by a, plus you are left with p. So, p of x is equal to a into minus b is minus ab by a plus b by 1. So, p of x is equal to a and 1 is LCM is a, minus ab by a into a is minus ab, plus b by 1 into a is ab, right. So, plus ab minus ab cancels. So, p of x is equal to 0 by a, that becomes equal to 0. This is the most generalized form what I am showing you here, right. So, in the linear polynomial, right, there will be at most only 1 0 other than minus b by a, no value other than this. If you substitute any other value in the place of x and simplify in this polynomial, you will never get 0. That is, the polynomial will never become equal to 0. If you want the polynomial to become 0, then you have to substitute only the value, that is minus b by a. Let us do here how it comes. So, p of x is equal to x plus 5. P of x is equal to x plus 5. In order to get the 0 of this polynomial, we have to equate x plus 5 to 0. Okay, I will equate this. So, x is equal to minus 5. Plus 5 comes to the RHS. X is equal to minus 5. Same value I substituted here. That's all. This is how the zeros of the polynomial are present, how they are designed. So, let us go with this example here. I will show you how minus 1 and 4 you are going to get as zeros for this quadratic polynomial, right. Let us take the quadratic polynomial. P of x is equal to x square minus 3x minus 4. So, in order to get the zeros of this polynomial, I am going to substitute, that is equate the value, that is polynomial equal to 0. Let us go with the sum and product method. X square into minus 4 is minus 4x square. We have to search two numbers. in such a way that if you add these two numbers, you will get minus 3x, and if you multiply those two, you should get minus 4x square. So best is minus 4x and plus 1x. So minus 4x plus 1x is minus 3x, minus into plus, minus 4 ones are 4x into x is x square. Okay, x square minus, instead of minus 3x, we will substitute these two values, minus 4x plus 1x, minus 4 is equal to 0. There are 4 terms, you can take a combination of 2 and 2 and select for the common. So here we have x as common, so x minus 4. Here you can take 1 as common, plus 1 into x minus 4 is equal to 0. So here you have 2 terms. In these 2 terms you can take x minus 4 as common, and you are left over with x plus 1 is equal to 0. So if m into n is equal to 0, either m should be equal to 0 or n should be equal to 0. That is, x minus 4 into x plus 1 is 0, then x minus 4 should be equal to 0, or x plus 1 should be equal to 0. Let us not take r, we will take and, as we are finding zeros. So x is equal to 4 is one of the 0, and x is equal to minus 1 is another 0. So this 4 I took it here, and this minus 1 I have taken here. So this is how you get the zeros of a quadratic polynomial. So this is very, very, very important. You have to remember this concept, right? Okay. Let geometrical meaning of zeros of polynomials. So geometrical meaning of zeros of a polynomial. So let us go with this. It's a very simple concept. Now I will take a simple polynomial, simple linear polynomial. From that we will start. For example, let p of x is equal to x plus 5. So in that example itself we will take. Okay, p of x is equal to x plus 5. So for this x plus 5, that is p of x, we will draw a graph for it. Graph for this. So in your 8th standard class, you have learned that when we draw a graph for a linear equation, you are going to get a straight line. So now also maybe we are going to get a straight line itself. To obtain a straight line, so minimum 2 points are required. One is the initial point, another is the terminal point. So therefore we will create 2 coordinates for drawing a straight line. Okay, so let us go with this. So let let us prepare this. Let y is equal to x plus 5. So put x is equal to 1. So that becomes y is equal to 1 plus 5. Y is equal to 6. So 2 points are ready now. So we'll put the truth table here. So just for our reference to draw the graph xy. So x is equal to 1 is 1 you are given, y is equal to 6 you have got. So let us take another table also. So x and x comma y are the coordinates. So what you have learned in your 9th standard coordinate geometry, how to plot the points. So that becomes 1 comma 6. So let us go with the equation again. Y is equal to x plus 5. So put x is equal to 2. So y is equal to 2 I have taken, so x in place of x I have to take 2 plus 5, so y is equal to 7. So I have got 2 values now. X is equal to 2, then y becomes 7, so the coordinates are 2 comma 7. So now let us plot these 2 points on the graph sheet, and we will draw a straight line, and by graphical method we will obtain the zero of this polynomial. For this polynomial I don't know which is the zero. I know, but I am telling you I don't know which is the 0. But by using the geometrical method, we will find out exactly where the 0 of the polynomial is located. Okay. So for that we need a graph sheet. So on the board, I cannot draw the entire graph sheet. So for that I have taken the help of the media here. So one thing, we can also take more than 2 points here, no problem in that. But still, to draw a straight line, we need only 2 points. One is the initial point, another is the final point or terminal point. So when we draw a line between the 2 points, we are going to get the straight line. So this is the graph sheet, which is ready made for us. Okay, let us plot the points now. So 1, 6. So this is the x-axis. We know you know very well. This is the x-axis, which is the horizontal line, and this is the y-axis, which is the vertical line. The two axes meet at a particular point, that is called as the origin. So you know all these things. This is the first quadrant, this is second quadrant, third quadrant, and the fourth quadrant. So here we have the first coordinate, that is 1, 6. So 1, 6 is 1 on x-axis and 6 on y-axis. So the point comes here, 1, 6. That is 1, 6. That's the point. Second point is 2, 7. The coordinates of the second point are 2 and 7. So 2 on x-axis, 2 on x-axis and 7 on y-axis. The point comes here, that is 2, 7. So now we will draw a straight line through it. So when we draw a straight line through it, we are going to get, I am going to draw a straight line through this. So the straight line passes through this point, that is, you can see here, it intersects the x-axis at this point. This is the x-axis, it intersects the x-axis at this point, and this is read as -5. You can easily see here. So these are the 2 points, 1, 6 and 2, 7. When I extend the straight line on, it can be extended. The line can be extended. So when I extend the line, it cuts the x-axis at -5. So better I can go with this. It passes through -5 here. So this is the point where the straight line intersects the x-axis, that is at -5. So this is the geometrical meaning of the polynomial, that is p of x is equal to x plus 5, to find its 0. So here, when you draw a graph for a linear polynomial, you get a straight line. And how to identify the 0 of that linear polynomial is that you have to extend the line. Just I got this is the initial point, this is the terminal point, I join this, but in order to obtain the 0 of the particular polynomial, I have to extend the polynomial until it crosses or touches the x-axis. The point at which the straight line touches the x-axis will be the 0 of that polynomial. So in the last example I just showed you that p of x is x plus 5. For this, the 0 of the polynomial is -5. So when we draw a graph of this, we get a straight line, and that straight line intersects the x-axis at -5, which shows the 0 of that polynomial. So let's go with the next example. Our graph sheet is clear. So let us go with another example here. Let us go with the quadratic polynomial and check out. So p of x is equal to x square minus 3x minus 4. We had taken the example already here. We got zeros as -1 and -4. So we will see mathematically, geometrically how we get the zeros of a quadratic polynomial. Right? We will see that. So remember the zeros. I hope one was -1 and another was 4. We know the zeros of the polynomial. Let us anticipate and get the zeros by geometrical method. Okay. So let us do the truth table to frame the truth table so that we get the graph. So as this is a quadratic polynomial, remember this, for a quadratic polynomial, when we draw a graph for that, or when we represent a quadratic polynomial graphically, then we get a parabola, a curve which is called as a parabola. When you draw geometrically a graph for a linear equation, that is a linear polynomial, we get a straight line, and for a quadratic polynomial, we get a parabola which is called a curve. So it comes. Let us go with that. So here, let y is equal to x square minus 3x minus 4. So let us go on giving values to this. So let x is equal to 0 we will give. So y is equal to 0 square here, minus 3 into 0 minus 4. So y is equal to 0 minus 0 minus 4, which is equal to minus 4. So let us frame the truth table. I will write the truth table here itself so that you can easily recognize the values. So this is x, this is y, and this is x comma y. So I gave the value of x is equal to 0, and I got y as minus 4. So 0 comma minus 4. This is the first coordinates. Okay. So let x is equal to 1 we will give. So y is equal to 1 square. That is in place of 1. That is x I have substituted 1 minus 3 into 1 minus 4. So y is equal to 1 square is 1 minus 3 minus 4. Minus 3 minus 4 is minus 7 plus 1 is minus 6. So when you give 1 as x, that is x is equal to 1, we get y is equal to minus 6. So 1 minus 6, 1 comma minus 6. Let us go with another value. So let x is equal to, let us give some negative values also. So as it is a curve, what we get, we need both positives and negative values because it lies in all the 4 quadrants. Maybe, let's see. So y is equal to minus 1 whole square, minus 3 into minus 1 minus 4. So y is equal to minus 1 whole square is 1, minus into minus is plus, 3 1 is 3 minus 4. So y is equal to 3 plus 1 is 4, 4 minus 4 is 0. So y is equal to 0. If you give x is equal to minus 1, we get y is equal to 0. So minus 1, 0, minus 1 comma 0. So this is the third coordinate. Let's go with the fourth one. So let x is equal to 2 I will give. So y is equal to 2 square minus 3 into 2 minus 4. So y is equal to 2 square is 4 minus 6 minus 4 plus 4 cancels, y is equal to minus 6. When you give 2, y is minus 6. X is equal to 2, y is minus 6. Sorry, 2 comma minus 6. This is the fourth coordinate we have got. Let us go with another one. So let x is equal to 3 we will give. So y is equal to 3 square minus 3 into 3 minus 4. So y is equal to 3 square is 9 minus 9 minus 4 minus 9 plus 9 cancels. So y is equal to minus 4. 3 and minus 4. 3 minus 4. 3 comma minus 4. So let us give another value 4. Okay, let us give another value 4. So let x is equal to 4. So y is equal to 4 square minus 3 into 4 minus 4. So y is equal to 4 square is 16 minus 3 4s are 12 minus 4. So y is equal to 16 minus 16 cancels. Y is equal to 0. So when you give 4, the value is 0. It is 4 comma 0. So we can also give 5, we can give 6, we can give 7, we can continue with that. So now let us try to plot the points on the graph sheet. Okay, let us go with the truth table here. So it is 0 comma minus 4. So 0 on x-axis and minus 4 on y-axis. 0 on x-axis, minus 4 on y-axis. So it's here, somewhere here. Okay. Then 1 comma minus 6, 1 on x-axis, minus 6 on y-axis, somewhere here. So then minus 1 comma 0. So minus 1 on x-axis, 0 on y-axis. So point stays on the x-axis there. As y coordinate is 0, the point lies on x-axis. 2 comma minus 6, 2 on x-axis, minus 6 on y-axis. So the point lies here. 3 comma minus 4, 3 on x-axis and minus 4 on y-axis. So the point is here. And then 4 comma 0, 4 on x-axis, 0 on y-axis. So the point lies on x-axis itself. So here, these are the points we have got. We will extend these points. I will join this point. I will join this. I will join this point here. I will join this. I will join this. I will join these two points, and I will extend this. And also at this side I will extend this. So this is the graph for a quadratic polynomial. So here we have got a parabola. So this curve is called as a parabola. Right. So this is this point is 0 comma this point 0 comma minus 4, 0 comma minus 4. This is the point, and this point is 1 comma minus 6, and this point is 2 comma minus 6, and this point is 3 comma minus 4, and this point is 4 comma 0, and this point is minus 1 comma 0. Right. So this is the parabolic curve, and this can be extended, and that can also be extended indefinitely to any length you want. So now let us analyze the zeros. So here, just it's very simple. It's not difficult. It's very simple. Just you have to look at the graph and analyze. That's the thing. No calculations, nothing. Just you have to look perfectly, see in the scientific method, and reach to the zeros. That's all. Very simple. So this is the parabolic curve. Now just see this, where this parabolic curve is cutting the x-axis at 2 points. The parabolic curve cuts the x-axis at 2 points. So now identify those 2 points. We'll just identify those 2 points. So here, one of the point is 0, minus 1. 0, after 0 it is minus 1. So and here 1, 2, 3, and this will be 4. So here the parabolic curve cuts the x-axis at 2 distinct points, and one is 0, that is one is minus 1 and another is 4. So I hope you can remember the last problem we had done. So what were the zeros of this quadratic polynomial x square minus 3x minus 4? It was 0 and minus 1 and 4. These were the 2 zeros. So here the parabolic curve cuts the x-axis at 2 distinct points, right? Therefore these 2 points where the parabolic curve cut the x-axis are said to be the zeros of that quadratic polynomial. So it cuts at minus 1 and cuts at 4. Therefore minus 1 and 4 are the zeros of this quadratic polynomial. This is very important. I hope you understood. So let us go with some more other possibilities on that. Some more other possibilities. Right. Now, in this graph sheet you can see y is equal to ax square plus bx plus c. This is the graph of a quadratic polynomial. So we have a parabolic curve here. It's a parabolic curve what I just showed you there. So this parabolic curve cut the x-axis at 2 distinct points, one at a, another at a dash. So here a and a dash are called the 2 zeros of this quadratic polynomial. Now the question arises, in the last problem when we draw the graph, the parabolic curve was something like this. In this graph, the parabolic curve is in the reverse direction like this. Why? What is the reason? So here, in this parabolic curve, in ax square plus bx plus c, here a is positive. In ax square plus bx plus c, if a is positive, then the parabolic curve will be in the upward direction. In this parabolic curve, the quadratic polynomial for this will be minus ax square plus bx plus c. So therefore, this parabolic curve will be reversed. So if a is negative, the parabolic curve will be reversed. If a is positive, then the parabolic curve will be in the upward direction. So whether, no problem, don't worry about this. Whether it is in upward direction or whether it is reversed, it doesn't bother. The thing is, how many zeros are there for this quadratic polynomial? So here, as this parabolic curve intersects the x-axis at two distinct points, therefore there are two zeros. Among them, one is a, another is a dash. Okay, we will go with the next one. So this is also a parabolic curve for a quadratic equation, that is quadratic polynomial, ax square plus bx plus c. Maybe I hope a is the positive here, so therefore we have got the graph in upward direction. So now this parabolic curve intersects the x-axis at two distinct points. At two distinct points, one is at a dash, another is at a. So therefore, a and a dash are the two zeros of this quadratic polynomial. Right. Next. Next. Come back. Okay. So this is also a quadratic polynomial, the graph for a quadratic polynomial. So we have got a parabola. So here you can see, don't get confused. Here you can see the parabola intersects the x-axis at one and only one point. And only one point. So remember my words, what I told you. A quadratic polynomial can have at most two zeros. It may also have one zero. It may also have no zeros. So here the possibility is it is having only one zero. Sir, what about the other zero? What about the other zero? So here, what the two zeros they are having, what the two zeros the quadratic polynomial is having, both the zeros are equal. That's all. Both the zeros are equal. So here maybe it is 1, it is this point maybe 2. So therefore, 2 is the zeros, that is 2 is the zero of this polynomial, where x is equal to 2 and also x is equal to 2. So x is equal to not two different numbers, not two different real numbers. X is equal to 2 and x is equal to 2. So therefore 2 is itself is taken twice. 2 and 2 are the zeros of this quadratic polynomial, because the quadratic polynomial intersects the x-axis at one and only one point. Right. Okay, next. Right. So it's a very complicated thing. So here we have a quadratic polynomial. So we have drawn a graph for this quadratic polynomial here. The quadratic polynomial graph, that is the parabola, doesn't intersect the x-axis at any point. It doesn't intersect the graph, that is any point. So x-axis is here, parabola is here. Sorry, if we extend it, what happens? If we extend it, it goes upwards. It will never come down. So therefore, this parabolic curve never intersects the x-axis at any point. So therefore, this quadratic polynomial has no zeros. So I told you earlier, I will tell you once again, a quadratic polynomial can have at most two zeros, or one zero, or no zeros. So this is how no zeros comes. So because the parabolic curve will never intersect the x-axis at any point. Okay, next. So this is the thing again, the same thing repeats. The parabolic curve is not intersecting the x-axis at any point. So therefore this parabolic curve has no zeros. That is, that quadratic polynomial doesn't have any zeros. So if we extend, it will go down, but it will never intersect. Okay. So this is very important. The things have changed. The quadratic, it's not a quadratic polynomial, it's a cubic polynomial. So y is equal to x cube minus 4x is a cubic polynomial here. So in a cubic polynomial, I told you earlier, at most it has 3 zeros. A cubic polynomial at most has 3 zeros. So it may also have 2 zeros. It may also have 1 zero. It may not have any zeros. That can also happen. So in this beautiful example, that is x cube minus 4x is a cubic polynomial because the highest degree of a variable is 3. Therefore it is a cubic polynomial. So when you draw a cubic graph for a cubic polynomial, you are going to get the graph like this. Here you can observe the graph of the cubic polynomial intersects the x-axis at 1 point, second this is the point, and third this is the point. So the graph intersects the x-axis at 3 distinct points. So therefore, this cubic polynomial x square x cube minus 4x exactly has all the 3 zeros. So can you identify the 3 zeros? This is minus 1, so this should be minus 2 here, that is given here. So this is passing through, the graph is passing through the origin of the graph. So therefore another 0 is 0, another 0 is 0, and the third 0 is, this is plus 1 and this is plus 2. So you can see here. So therefore there are 3 zeros for that x cube minus 4x cubic polynomial, that is minus 2, 0 and plus 2. These are the 3 zeros. Okay, next. So this is another cubic polynomial, y is equal to x cube. So I told you y is equal to x cube is a cubic polynomial. It may be a monomial, it may be a binomial, or it may be a trinomial. In the last class I had told you. So it's a monomial here. Whether it is a monomial or binomial or trinomial, you will get the graph. Note in that. So this is the graph for that. So if you observe here, correctly if you observe here, it passes through the origin. Exactly passes through the origin. It won't cut the x-axis at any other points. So this cubic polynomial y is equal to x cube has only 1 zero. Has only 1 zero. It doesn't have other 2 zeros. It has only 1 zero. Okay, next. So this is again we come across another cubic polynomial, that is y is equal to x cube minus x square. So in this cubic polynomial, you can see the graph here. It cuts the x-axis at 2 distinct points. One is at origin, another is at plus 1. So therefore there are 2 zeros. One is 0, another is plus 1. So therefore it has 2 zeros. It doesn't have the third zero. So a cubic polynomial can have at most 3 zeros, what you saw in the first example. The second example you saw 1 0, and in this example you are seeing 2 zeros. So how to identify the number of zeros of a polynomial in a given graph? Very simple. Look at the graph, at how many points, distinct points, it cuts the x-axis. So here it cuts the x-axis at 2 distinct points, therefore it has 2 zeros. If it cuts at 1 point, it has only 1 zero. If it cuts at 3 distinct points, it has 3 zeros. Next. Okay. Some examples of different quadratic polynomials, linear polynomials and cubic polynomials, biquadratic polynomials. Graphs are given here. So starting from 95. So for this, it's a straight line. It's a straight line. Straight line means it's a graph of a linear polynomial. So a linear polynomial, for that it has how many zeros? It doesn't have any zero because it doesn't cut the x-axis at any point. So it has 0 zeros. In the sense it has no zeros. We write this. Okay, next. Second one. Here we have another graph. In this graph, which is given by a polynomial. A polynomial has given this type of graph. In this graph, the graph intersects the x-axis at only 1 point. So therefore it has 1 0. Okay, next. Another one is given here. Some p of x, some polynomial is there. For that polynomial they have drawn the graph. This is the graph for that, and the graph of that polynomial intersects the x-axis at 1, 2 and 3 points. So therefore it has 3 zeros. Okay, let's go with that one. So by seeing that you can analyze, that's a graph of a quadratic polynomial. So it intersects the x-axis at two distinct points, here and here, therefore it has two zeros. Okay, nice. We'll go with another one. So this is a graph of some polynomial. So this graph intercepts the x-axis at 1, 2, 3 and 4. So as this graph intersects the x-axis at 4 distinct points, therefore it has 4 zeros. Now at this position, can you guess the polynomial, type of polynomial? 100% you are right. It's a biquadratic polynomial, because the power of a biquadratic polynomial will be equal to 4. Therefore the graph cut the x-axis at 4 distinct points, therefore it has 4 zeros, and the type of polynomial in that is a biquadratic polynomial. So here we will go with this. Here the graph cut the x-axis at 1 point, here 2 point, this is the third point, and this is the fourth point. So again it has 4 zeros, so therefore it is again a biquadratic polynomial. Next. Okay, I hope until now we have enjoyed the entire session. So it was the graphical method of representation, that is representation of polynomials to analyze the zeros. So in other words, as per your textbook, the graphical representation of zeros of a polynomial. I hope you understood this. It's very, very important. Just look at the graph, see the graph at how many points it cuts the x-axis, count the number of points, and they are that number of zeros of the polynomial. If it doesn't cut the x-axis at any point, then it has no zeros. If it cuts at 1 point, it has 1 zero, 2 points, 2 zeros, 3 points, 3 zeros. So we will come to the end of this session. See the textbook. In the textbook, an exercise is given, some graphs are given to you. Identify the number of zeros in the following graphs. It is given to you. Just go with that, answer those questions and send it to me through the WhatsApp. So I hope you are practicing the problems well. So understand theory, because just like sequences, polynomials are also based on theory and also on problems. Unless you do not understand the theory, you will not be able to solve problems on that. So problems are very classical. In the coming days, that is tomorrow's class, I will be going with some more problems on that. So in today's concept, value of the polynomial, zero of the polynomial, graphical representation of zeros of the polynomial are the 3 topics covered. So I wish you all the best. Stay home, stay safe and keep learning. Thank you.